Hello everyone, welcome to back my channel. Our brains are incredibly adaptable. This ability to change and rewire itself is called neuroplasticity. For a long time, scientists believed that the brain stopped developing after childhood. We now know this is not true. Our brains are constantly changing throughout our lives. They form new connections and pathways as we learn, experience new things, and even age. This concept of neuroplasticity is revolutionizing how we understand the brain. It has profound implications for learning, recovery from injuries, and even aging. It means that our brains are not fixed but rather are constantly evolving. The brain adapts to new information and experiences in several ways. These changes can be chemical, structural, or functional. Chemical changes involve the release of neurotransmitters, which are chemical messengers in the brain. These changes happen quickly and support short-term memory and learning. Structural changes involve the physical connections between neurons, called synapses. When we learn something new, these synapses can become stronger or weaker, and new connections can even form. This process takes longer, but leads to long-term memory and skill development. Functional changes refer to how different areas of the brain are activated. For example, when people learn to read Braille, the area of the brain responsible for touch processing in the fingers used for reading becomes larger and more active. One of the most important findings from neuroplasticity research is the power of practice. The more we engage in an activity, the stronger the neural connections associated with that activity become. For instance, London taxi drivers who must memorize the city's complex layout have a larger hippocampus, a brain area crucial for spatial navigation. However, learning is not a one-size-fits-all process. What works for one person may not work for another. This is where personalized learning comes in. Factors such as genetics, age, prior experiences, and learning style can all influence how we learn best. Neuroplasticity offers hope for individuals recovering from brain injuries like strokes. After a stroke, the brain can rewire itself to compensate for damaged areas. This process is supported by rehabilitation therapies that encourage the brain to form new connections. Research in stroke recovery is crucial for developing more effective treatments. By understanding how the brain adapts after injury, we can develop targeted therapies that maximize recovery and improve the quality of life for stroke survivors.